Appreciate you attending the session. We're going to talk about patching and the challenges involved. Just listed a few of the items on this slide that shows the different types of patching challenges. A lot of the mission critical apps require manual patching and monitoring, and what I'm speaking to here is where you have a multi-tiered app that requires certain validation tasks take place, you stop services and so forth before you patch, and then after you patch, you make sure everything's up and running. And that's part of the post-patching validations I talked about, where you can make sure you can get to a website and so forth. Sometimes you have difficult maintenance windows, 2 o'clock in the morning on a Saturday, or 1:30 on a Wednesday, the third week of the month. So those type of maintenance windows can be difficult. And then of course, if you're trying to do something really challenging like the Saturday after patch Tuesday, a lot of software packages can't handle that kind of thing. So it can be a challenge, and those of course are your after hour work that you have to do to actually patch the machines and making sure you're in compliance. And the big thing we want everyone to understand is these challenges are out there, everyone has them. And we've designed Beekeeper to solve these issues for you. So some of the technical features within Beekeeper, it integrates with Microsoft System Center, Configuration Manager, Operation Manager, Orchestrator, and your IT help desks, service managers. It is an agentless solution. We do not put an agent on the server. We utilize the SCCM, System Center Configuration Manager agent that's already out there to do the patching. We allow the agent to be the one that talks to each service. We have widgets that highlight the potential issues within patching, so you can see an overall status of your environment, and we have the ability to automate complex or custom maintenance processes. Like I was saying, if you have to do your patching on the Saturday after patch Tuesday, that may not always be the second Saturday of the month, so you can't say, well, let's do it on the second Saturday. It very well could be the third. So that's why we have the ability to process and create schedules like that. And then, of course, the other item with validations, where they allow you to get real fancy with your ability to monitor and maintain systems. We have a built-in maintenance for failover clusters and exchange tags. We take care of pausing the nodes in a failover cluster, making sure that we move resources over to another node in the cluster before pausing the node and being able to patch the pause node. Same thing with Exchange. We look at where the databases are, who has the least amount of databases and or resources available, move the items off of that and go on to the next one while we're patching. During your maintenance, we are providing email notifications of the progress when we move on to the next node, and the successfully patching of however many updates are applied during that process. And as I said, our scheduling engine allows for the complex maintenance of what we call offset scheduling. If you want to do the Saturday after patch Tuesday, you would simply create a schedule that has the primary date of the second Tuesday with a 4-day offset, allowing it to move to that Saturday every month, and then we would be able to meet that schedule. And of course, we can work with your existing patch processes of SCCM, and whether you need to automate those, we can work with you to do that. For our demonstration today, I have a multi-tier application that we're going to utilize to show Beekeeper's features. The important thing here is that it is like I said, multi-tiered web front end to application servers and a clustered database on the back end. Each of these tiers have multiple machines and have a load balancer in front of them so that there is redundancy, and we'll work with that to make sure that the app is up and available during patching, where as a manual patching process, you may not have thought to do that or may not have realized it was possible. So I guess we'll go ahead and jump right into the demonstration. So I will take control and I will show my screen. So here we are at the Beekeeper interface. This is the UI. It is web-based. So you just go to the Beekeeper website on your Beekeeper server, and you're able to just jump right in. As you can see here, we've got a dashboard that defines what's in the system, what kind of patching is going on, and the overall health. So I'll go ahead and jump right in. I've done some of the configuration beforehand, but I did want to show you a few things, and so I'll go for the items. The first thing we had talked about was in this killer app, you have your servers. So what we'll go ahead and do is go into our server and cluster blade. We will go to our application group, because as you can see, we've got 3 different delineations: application group, machine, Microsoft Exchange tag, or a failover cluster. Since the servers involved here, those 2 tiers, the web server and application server, are not a DAG or a failover cluster, we go into application group. I've already defined them, most of the information about them, but we have a dev environment that we could also define. So we could go ahead and give our name to this application group. It's the killer app dev app servers. So then we add the individual nodes. They'd be named like, KA dev app 01, and we add that into our list of nodes, and we put in an email address who would receive the notifications as patching continues. We can enable SCOM maintenance mode. So as I said, we interface with System Center Operations Manager. We can place a node as we patch it into maintenance mode. If there's a failure trying to put the item into maintenance mode, we can ignore that, and then of course the number of minutes. Down here at the bottom is a very important item that a lot of companies utilize: the failure options. Not all patches the first time they applied will apply correctly, because of each server may have its own little idiosyncrasies that cause an issue. So we can say whether we want to continue patching other nodes in the group. If an update fails, we can exclude the update that failed on the previous node. So if you have a mission critical app like this one here, you may not want to try to apply the same update to the second node if it failed on the first node. You want them to be in the same compliance, so you can do that. So you click that, and then of course you can continue on any failure if there's an issue there. So that would be how that information is put into the system. So we would save our definition, and now we have our dev server added in there. So in our application, we got our web servers, we got our application servers, and we also have our clustered database. As you see, I have both application servers and the web servers defined. We'll come back and talk about their patching and validation tasks that may be needed with that, but I'll show you quickly the SQL server. It is a Windows failover server that is also a SQL cluster. So we just put the name of the server in. When we define it, we just give the name of the server and the same information that we would before. You wouldn't give it, you don't have to give the name of the nodes, you give the cluster name. So in this case, as you can see, there's just that single name. It will then work itself out. Beekeeper will then query it, knows that it's a cluster, ask for the nodes, and work through each node in succession. So that's the beginning of our SQL cluster. If we go back to our application servers, I do have a couple documents here I wanted to show you. Our application server admin passed along the patching process he's doing right now. So what he does right now is he first starts by patching the SQL cluster one node at a time. Since it's a active passive cluster, it will be able to fail over. Then he removes app server 1 from the load balancer, patches it, adds it back, does the same for the app server number 2, and so forth. And then at the end, he verifies that IIS is running. For some reason, he only wants us to check that on Web 1. Could be any number of things. You know, obviously he's found where that one particular item has been an issue on Web 1 and always goes back and makes sure IIS is running. And then, you know, so forth. We move into Web 2, do the same thing there, removing it from the load balancer, patching it, adding it back. And then at the end of the process, he runs some test transactions, making sure the database is active, make sure the app server's probe service is active, and then running a test transaction. With Beekeeper, we can change this up and run things in parallel. Obviously, he was one person, so he was stepping through one at a time. With Beekeeper, what we can do is we can kick off the patching of the SQL cluster, the app servers, and the web servers all at the same time. We will still keep the idea of patching the SQL cluster one at a time. We will begin patching app server 1, and then following the items he had by removing it from the load balancer, patching. After we're done, we test the probe service and the transactions, adding it back. And then in cycle number 2, we come and get to the second nodes in each of these items. And at the end, we can test our services just as they ask. So to fulfill these items, we use what's called validation tasks. So first of all, we'll go to the app server, and as you can see, we got an edit button here for the validation tasks. And what we have here is we have it removing the load balancer, checking the service, running a transaction, and adding it back. Now, because we are able to do these one at a time, we are telling it to be done before we do any patching, pre-node maintenance. And then when we're done with the node, we check to make sure the service is running, because without the service running, those transactions aren't going to work. So we have sequenced those items. First, we check the service, then we run the transaction, synthetic transaction, and then at the end of pre-node maintenance, we add it back into the load balancer. We're doing this on all nodes, so as each node is processed, all 4 of these items are run upon it. So that's the application server. Now, if we look at the web servers, we can see that they're very similar in what's going on there. We are removing it from the load balancer. We're patching, then when we're done, we're making sure we can get to the URL. And then once we're done there, we get in here. Now, one thing I forgot to do, if you remember on his instructions, he said to make sure IIS is running. Well, we can do that by just checking the World Wide Web service. So we do that by this little validation task, which I'll show you in a minute. It uses the check service validation task, but we'll go ahead and add it. So we add it. We want to make sure that it's running. So at node end, once we're done patching and everything, we do it node end, and because I had semi-configured this earlier, our sequence numbers are correct. So we make sure IIS is running before we check the URL. But we only want this to run on Web 1. So by placing this constriction on it, node 2 will not run this task. Even though the sequence number is 2, it's going to be the only thing it runs on node end for web server number 2. So that's our validation tasks for the web servers. We'll go back here and look at our SQL real quick. So our SQL cluster, the only thing we're doing here on cluster end, once we're done with patching for both of our clusters, are running a query against the active tables and making sure everything's fine in the database. So these are all little PowerShell things just to show you. Our application admin had sent, like adding to the load balancer, is just a short little PowerShell command that we then can import into Beekeeper to run. I have added a few things specific to Beekeeper. This is a variable within Beekeeper. It picks up the node name of the item that's being patched at the time this PowerShell is run, so that we'll see information in the log, and that's what these two lines are doing, are writing information to our log. So that's just a quick overview of how to get things into it. I did want to show our validation tasks. We have where you can check your desired state configuration that you may have created to where you can test it or apply it after a patching period. You can check a port on the server, 443, 25, whatever you need to there. Check to see if a process is running or not. Our service check, let me show you that real quick. We have two of those. We have the one where we're checking the probe service, so I'll just go ahead and edit that. We are checking the service, called Killer App. We're looking just for the status. We can do a stop, start, or restart of a service in this kind of interaction, and what we expect the state to be. And if it's not started, then we want to fail. So therefore, we don't try to go do any more items. If the service hadn't started, there's obviously an issue, and you want to check that before we continue patching. And the same thing here with our IIS service. It's doing the exact same type of operation. We're looking at the World Wide Web service, and we want it to be started, and if it's not, we stop on our failure. So that's a quick little overview of bringing items into Beekeeper and patching them. We've defined the servers to Beekeeper. We have given the validation tasks that are admin requested. And now we need to actually schedule the patching. So we go down to schedules. I already have a schedule out here. I'll just show you that. The schedule itself is just like I had mentioned. It's the Saturday after Patch Tuesday. The next time that's going to happen will be next month. So we can see that on our calendar date, if we look forward, the 18th is that Saturday. Patch Tuesday would be the 14th, and then, like I said, we've got a scenario where the Saturday is not the second Saturday; it's actually the third. So that's how we use our relative day frequency. It's the second Tuesday of the month, offset by 4 days. We have 3 different types of frequency. Once, if you just want to run it one time and you're done. A reoccurring fixed day, the 17th of the month, the 12th of the month, whatever you want to do there. And then this relative day reoccurring like I have here. Again, every month, if you're only doing it once a quarter, then it would be every 4 months, or 3 months, excuse me. And then the day, offset day there. Execution timeout is how long you expect the patching cycle to take. Our Killer App admin may have taken 3-4 hours to do all that, maybe less, because he was stepping through each system. Beekeeper, through its automation, can do this in parallel and can do it quicker without human error. And we're able to automate these functions to make it easier. It's the automation that gives you that time saving. So here's our schedule. Now to link the two, to link our schedule to our servers, we have execution jobs. So this is where we create that link and actually set the schedule or scheduling of the server. If you do not create an execution job, the patching will not take place because, like I said, the schedule doesn't have any relationship to our servers at this point. We go into our execution DOM, create a new one. First thing we're asked to do is select the servers involved. So we have our SQL server, we have our app server, and we have our web servers. This way, they're all going to be executed at the same time in parallel, one node at a time, so that there is no downtime. Redundancy of the application itself kicks in. Your load balancer allows for that to happen. So then we go on to the schedules. We choose our schedule, and we can go forward. I want to point out we also have this execute immediately option. If you have to get patches out immediately for a 0 day, you would choose this option and then give the execution timeout that you expect. In our case, we want to schedule it for November 18th at 1 a.m. We are looking at the information again. This is, are you sure? Everything looks fine. We say complete. It has successfully created the job. So now on November 18th at 1 a.m., this will happen. I have already ran this cycle in on another system, so we can see the output. Just like your baking shows, I'll pull it out of the second oven to where we can see it actually working. I do want to show you one item here up here. I created that dev app 01. It does not actually exist. So what's happened here is the health for SCCM has gone to a warning scenario because it cannot connect, because beekeeper cannot connect to the WMI namespace for SCCM on that box. It can't connect to it at all. So this way you'll know if there's issues with your systems that we had discussed earlier. So now we go over to system number 2, and I have jumped down to the history tab. So in the history tab here, we can see that I have patched these items and they succeeded and how long they took. So the SQL cluster itself, I'll just do a quick overview of it. The SQL cluster took just 26 minutes to patch. The reason for that, node number 2 didn't need any patches. It had the patches installed already. So, you know, possibly someone had done some testing with it earlier or so forth. But you can also see out here where it lists the patches that were installed on node 1. Node 1, 24 minutes. And one thing I want to point out down here at the bottom is where it did the testing of our query to the API, our query to the database. So that's a quick overview of what goes on our SQL cluster. The other thing I want to show you is, like I said, these three here, they all started at the exact same time. So our application servers took 87 minutes to patch both of the servers because they had 17 patches to install, much higher rate. So again, if we're looking at our app servers, we'll see here where it removed them from the load balancer, did its processing, made sure the service was active, ran our synthetic transaction, and then added it back to the load balancer. So these are the items you can see in the history. I will show you two other things. We have this download button. So if there is an issue and you need to send it to Infront support, you can do that at beekeeper support at infrontconsulting.com. And this other item is the rerun. So if it did fail, perhaps a node was paused on your cluster, and you can go back and put it back into production and then rerun it. The last thing I want to show you here is our web app. Again, the exact same thing, 17 patches. Some of the, you can see here that node 2 took considerably longer, 30 minutes longer. Obviously, it was on a slower hypervisor and just took some time to get it to be done. But the important point here is that to patch this application, the total time it took was 160 minutes. Whereas instead of adding these together because you were doing them one at a time, they're in parallel. So that took 2 hours, 40 minutes instead of, 3, 5, 7 hours, however long it may have taken. And we can see here in our Web 1 where we made sure that World Wide Web is active. And then if we go, actually, I think I had a typo there, so I'm sorry about that. But it was in Web 1's output. Web 2, we don't have that same look. It just did the URL test and not the IIS test. So we have all of our validations come through. Everything was successful, and it did actually operate. I didn't show the overview look, but I'll do that on the cluster so you can get an idea of what happens when you're patching a cluster. We're checking the health. We have sorting node by passive first, triggering maintenance, put the node into paused, and then we patch, come back out. And an important point to remember is that these guys will redistribute, and that's the important point, is at the end we actually look to see how things were before patching and put them back that way so that the loads are the way you wanted them, in case you were specific on that. And then, like I said, you don't want to be the one sitting here watching this happen. The point of it is to get the emails. So here is a email completion report for our web servers. We can see that it started at 1 o'clock, ended a little after 3, and how long each of them took, how many patches were installed, and then the validations. Of course, we want green across the board there. Some of the other emails you get are the individual app servers. I'm complete with that particular server. I've completed this one. I'm moving on to the next node and so forth. And then, of course, our app server, you see the same type of information. The big thing I want you to take away from this is, although this may not be as interesting to your SCCM administrators, the application owners who are the ones having to do some of the manual patching can really see the value of being able to run validation tasks, being able to check URLs, check services, make sure they're all running accordingly, and get the information that's needed. So that pretty much wraps up the demonstration portion at this point. The big takeaway is our validation tasks. Those are the neat feature of Beekeeper, and that's what allows you to be able to automate the patching cycle to where you don't have to be there to make sure these individual things are up and running. Beekeeper does that for you, sends you the email to let you know that it's okay, and you can move on.
That's great, John. You had one more slide as part of your presentation, so
yep.
I'll take control and
sure.
Share. That was awesome.
Yeah, the validation packs. We talked a bit about that in the presentation. I showed you the validation tasks. We've created a group of validation tasks by application type, and those are called validation packs. Such things as Exchange, Windows Cluster, Hyper-V, Cognos, WriteFacts, Link, SQL Server. So all those items we've had experience in a number of clients helping them patch these items. Obviously, most of your applications are going to have multi-tiers, so we're going to have SQL in the background, on a Windows cluster, so things are combined, but they're all there and useful. Exchange, like I said, we have the ability to patch exchange tags. We have just, in the next version, which we'll be releasing soon, have the ability to patch an IP list tag, a exchange database availability group that does not have a administrative access point. So there's no IP connected with the quote unquote cluster. Exchange just manages that, and we now can patch that as we can a regular DAG with an administrative access point. But that's about all I have at this point.